Hello dear students, today we are going to solve some numerical problems related to the deflection of electron in the perpendicular uniform electric field. First numerical problem is a beam of electrons moving with velocity 10 to power 7 meter per second enters midway between two parallel horizontal metal plates 5 cm long and 2 cm apart with a potential difference of V volts between them. Calculate potential difference V if the beam is deflected so that it just grazes the edge of the plate. Take specific charge E by m of electron to be this much. Now come to the solution. Suppose these are two parallel metal plates. Length of the plates is 5 cm, which is 0.05 meter, and distance between two plates is 2 cm. This is electron moving with constant horizontal velocity 10 to power 7 meter per second. So its vertical components u, y will be 0. Now according to question, the deflected electron just grazes the edge of the plate. Means while coming out of the electric field, this beam just touches the plate, edge of the plate. So deflection y will be half of d. Means total d is 2 cm, therefore y will be 1 cm. This y will be 1 cm means 0.01 meter, because electron is entering midway between two plates. Now we have to find the potential difference V. Now come to the solution. We know that y is equal to half. Now vertical deflection y will be equal to 1 by 2 a y into t square, that is 1 by 2 e upon m into x upon u x square. This is y. This gives the value of E as 2y u x square upon x square upon E by m. And putting the values, we can find the value of A. Now E can be replaced by V by D. So this is V by D. Now V will be equal to 2y u x square into d upon x square into E by m. Now putting the corresponding values y, ux, d, x and E by m, we can find the value of V as 90 point, this will give 90.9 volts. Next question is, a beam of electrons moving with velocity 10 to power 7 meter per second enters midway between two parallel horizontal metal plates 5 cm long and 2 cm apart with a potential difference of 90 volts between them. Calculate the magnitude and direction of the resultant velocity of the emerging beam that grazes the edge of the plate. The specific charge of electron is given to be this much. So in this case, now come to the solution. These are two parallel metal plates. The length of plates is 5 cm, that is 0.05 meter, and separation is 2 cm, that is 0.02 meter. Electron enters midway between two plates with horizontal velocity ux is equal to 10 to the power 7 meter per second. Therefore, vertical velocity will be 0. Potential difference between two plates is 90 volt, with suppose upper plate being positive. While coming out of the electric field, the beam just grazes the upper plate. So this deflection y will be half of d, means 1 cm, that is 0.01 meter. Now we have to find resultant velocity v at exit point. Now we know v is equal to, at exit point, this point, resultant velocity will be equal to u ax square plus b y square. Suppose this is equation 1. Electric field between two plates will be E is equal to B by D. Capital B means voltage upon D. B is 90 volt and D is 0.02, that is 45,000 volt per meter. Therefore, acceleration will be, or therefore By square is equal to B. Therefore By square will be equal to Uy square plus 2Ay into S, where S is equal to Y. Therefore By square will be equal to 2 E is 45,000, E by M is 1.8 into 10 to the power 11, 2 of E by M, E by M into Y, that is S, 0.01, and its value comes to be 1.62 into 10 to the power 14. Therefore, By will be equal to under root of this 1.62 10 to the power 14, and this will be 1.27 into 10 to the power 7 meter per second. Now from equation 1 we get, therefore from equation 1 we get resultant velocity at exit point as B is equal to Ux is 10 to the power 7 square plus By is 1.27 into 10 to the power 7 square. On simplification we get B as 1.61. This is 1.61 into 10 to the power 7 meters per second. Now, if theta is the angle between resultant V and Ux, where tan theta will be equal to By upon Ux, By upon Ux. Therefore, theta will be equal to tan inverse of By upon Ux. values are known. This is tan inverse By is 1.61 10 to power 7 and Ux is 10 to power 7. So we get theta as 58 degree. Thus the resultant velocity at the exit point will be this much, which makes angle 58 degree with the horizontal. Next question is, an electron beam moving with velocity with horizontal velocity of 10 to power 7 meter per second enters midway between two parallel metal plates 4 cm long and 3 cm apart, having potential difference of 300 volts between them. Find the deflection of electron beam just while coming out of the field. Specific charge of electron is given to be this much. Solution: we know that y is equal to 1 by 2 E upon m into x upon u x whole square. Here x is 10 to power 7 meter per second. E is V by D. V is 300 volts, and D is 3 cm apart, means this is D, 0.03. X is length of plates 4 cm, that is 0.04 meter. E by m given to be this much. So y will be equal to 1 by 2 E 300 upon 0.03 into E by m 1.8 into 10 to power 11 into x is 0.04 and ux is 10 to power 7 its square. On simplifying, we get the displacement y just when coming out of the field as 1.44 into 10 to minus 2 meters.